Hey guys, today we're going to be using identity property and change of base to solve equations. Well, I'm going to just go ahead and start off with this very first example. So I want us to remember that exponential and logarithmic functions are inverses of each other. So to be able to solve this equation, we have to use inverse operations, just like any other type of equation in algebra. The base here is 4. So the inverse of base 4 would be log base 4. So on both sides of that equation, I'm going to write log base 4 in front of the 4 to the x, and I'm going to write log base 4 in front of the 7. We should remember from our properties unit that this is a power rule here. So we can bring this x to the front. We have an identity here, log base 4 of 4. Remember, 4 to the first power is 4. This is an identity. This basically cancels out. So if that log base 4 of 4 is just 1, then all we have left here is x equals log base 4 of 7. Now we can use change of base to evaluate that log base 4 of 7. Remember, we want to put log of the big number on the top, and the base always goes on the bottom. In my calculator, I can do log 7, make sure you close the parentheses after 7, divided by log 4. Again, close those parentheses, hit enter. And we get 1.4036. We're going to round to the nearest thousandth. It's tenths, hundredths, thousandths. I'm not sure if I spelled thousandth right, but not an English teacher over here, a math teacher. So because this 6 is 5 or more, we're going to let that 3 soar to a 4. Oh, so many rhymes. 1.404. I put the approximately equal to symbol because we're rounding. You guessed it, we're going to try one now. Go ahead and copy, pause the video, try it on your own. Round to the nearest thousandth. No idea if it has an S or not at the end, but whatever. And come back when you're done so we can check it. As you can see, we used the identity property as well as change of base to solve this equation. First, I started off by doing log base 7 on both sides. I brought this exponent of x down to the front. This log base 7 of 7 is an identity, which cancels out. This is equivalent to x times 1. So this would just be x left on the left side. Over here, I used change of base, log of 43 divided by log of 7. And in my calculator, I rounded to the nearest tenths, hundredths, thousandths. Because 8 is 5 or more, I went ahead and let that 2 soar to a 3. All right, so let's go ahead and look at this second example. Now, as you can see, I have an entire expression in my exponent. In order to get this down to the front, I need to use that identity property. I'm going to skip a couple steps here now that I kind of have the idea. So I know that I want to do log base 8 of 8 on both sides. Whatever you do to one side of the equation, you do to the other. That's a normal thing that we've learned in algebra throughout our years. I can go ahead and bring this 2x minus 3 down to the front because of that power property. And I know that this log base 8 of 8 is 1. So all that I'm going to have left on this left-hand side is 2x minus 3. And on the right-hand side, I'll still have log base 8 of 7. Now, I'm not going to use change of base yet. I'm going to go ahead and get x by itself, and I'll show you how to do this part in your calculator all together. So remember, this is just going to be some nasty, ugly decimal. It's a number. So I'm just going to pretend like that is a number. I'm going to cover this up. Excuse my quarantine ugly nails. And I'm going to solve an equation like I would normally. So I'm using inverse operations still. I used an inverse operation to get rid of this 8 here, and I'm going to use inverse operations to get this x by itself. So I'm going to go ahead and add 3. I'm going to go ahead and divide by 2. And I'm going to show you how to do this whole thing in your calculator. Okay, so the very first thing that I'm going to do is the change of base for this log base 8 of 7. I'm using order of operations. The numerator is its own set of parentheses, so I'm going to evaluate this numerator first. So I'm going to do log of 7 divided by log 8 first. So log 7 divided by log 8. And I'm going to get a decimal. Now, I'm not going to touch my calculator. I'm not going to round yet. I am going to add a 3 to this number here. So again, I'm not going to clear anything. I'm just going to click plus. See how it says answer in there? It's taking my answer that's already in the calculator, and I'm adding 3. So I've done this part already. I've added 3. I have not rounded yet. I have used every value in my calculator. I'm now going to divide by 2. Now I can round. If I round too soon, my answer is going to be skewed. NASA does not round in the beginning. They only round at the end. Watch Hidden Figures if you haven't already. Tens, hundreds, thousands. This 8 is going to bump this 7 up to an 8, so 1.968. All right, so let's go ahead and look at example 3. The first thing that I want to do is isolate this exponential expression here, which means I want to get this part by itself. So I'm going to use inverse operations to get rid of that minus 2. So I'm going to add 2 on both sides. 8 plus 2 is 10. Now that that exponential expression is isolated on one side, I can go ahead and use my identities. So I'm going to do log base 7 on both sides of this. I'm going to just squeeze this one in, log base 7. I know that log base 7 of 7 is an identity right here. So I'm going to bring that 2x to the front. And I know that this part here cancels out. So I have 2x left on the left-hand side. And I have log base 7 of 10 on the right-hand side. Just like I did in the last equation, I'm not going to evaluate this first. I'm going to do this all in my calculator at one time so that I can get the most exact answer as I possibly can. So in my calculator, I'm going to do log of 10, doing change of base, divided by log 7. So I'm evaluating this numerator here first. I'm not going to round here. Again, I'm going to leave my answer as it is in my calculator. I'm just going to click divided by. See how it says answer here? It's taking that exact decimal, and I'm going to go ahead and divide that answer by 2. Now I have 0.5916. I'm going to go ahead and round that to the nearest thousandth as well. A 6 bumps that 1 up to a 2. So let's compare these two. Notice that in example 2, that our exponential expression was isolated on the left-hand side of the equal sign. And in this third example, that exponential expression was not isolated. We had to isolate it first. We also had a little bit more going on in this exponent in this first example. So we had a little bit more going on when we were trying to put that in our calculator. Okay, so here's a couple for you to try. Make sure you look at number 2 and number 3 example to try and solve these equations. Be careful with B. Think about what this base is and what the inverse of base E is. Go ahead and pause the video, copy, solve, come back when you're done. In this you try example A, I went ahead and did log base 16 on both sides because that exponential expression was already isolated on the left-hand side. I brought that x minus 7 down to the front, and log base 16 of 16 is equal to 1. So all that was left on the left-hand side is that exponent x minus 7 that was brought down to the front. On the right-hand side, whatever I did to the left, I had to do to the right. So I also have this log base 16 of 19. And then I isolated x by adding 7 to both sides. I'm going to go ahead and put this in my calculator live. Well, not really live, recorded. So I'm gonna follow order of operations. I'm going to evaluate this log first, and then I'm going to add 7. So I'm gonna do log 19 divided by log 16, change of base. I'm not going to round yet. I'm just gonna go ahead and take this answer and add 7. Notice I didn't press anything but plus 7. And I get a new decimal. I'm gonna go ahead and round that to the nearest thousandth. So 8.062. That 9 raises that 1 up. It lets it soar up to a 2. For the U try, letter B, I went ahead and isolated that exponential expression e to the x minus 1 by adding 5 to both sides, which gives me e to the x minus 1 equals 10. Now, in order to get rid of this base, I'm not going to use log base e. I'm going to use natural log, which I'm sure you remembered to do. So on this side, I would use natural log, and I would do the same to the right. Whatever I do to the left-hand side of the equation, I need to do to the right-hand side of the equation. That x minus 1 can be brought to the front, which would leave me with x minus 1 times 1. Natural log of e is equal to 1 equals natural log of 10. That is an ln. Many of my students were writing the letter I as an igloo and then an n. This stands for natural log. Natural is the n part. Logarithm is for the log. It's not igloo natural or natural igloo. This is an L as in logarithm. Now that we've cleared up that ridiculous confusion, let's go ahead and finish up this equation. I'm going to go ahead and isolate that x by adding 1. In my calculator, I'm going to press the natural log button because this is L as in logarithm of 10. Go ahead and hit enter. I'm not going to round this. I'm just going to go ahead and add 1. My answer is 3.3025. Because this 5 is 5 or more, we're going to go ahead and let that 2 soar. This video for my kiddos is good for S.5 and S.6 for your IXLs. See you later.